Okay, so now we're going to work in the other direction, and we're going to convert our quadratic functions from standard form to our vertex form. So as a reminder, standard form is the form of y equals ax squared plus b times x plus c, where a, b, and c are our coefficients or their constant values. The things that we can understand or find from standard form is our y-intercept, which we can use our c point because the y-intercept would be at 0, c on our Cartesian plane. We can also use the a from standard form just like we did in vertex form, where it tells us the vertical reflection and dilation that is going to happen. Now, we're going to convert it to our vertex form, which is the first form we learned about, where we have indicators a, h, and k. Our vertex is going to be found at h and k. Our vertical reflection, again, is told by a, which is the same value in standard form. H will tell us if this parabola is moving left or right, or has a horizontal translation. And k will tell us if this parabola is moving up or down or has a vertical translation. So we're going to start with our standard form function, or our standard form quadratic equation of y equals 2 times x squared plus 12x plus 22. And we know that a is equal to 2, b is equal to 12, and c is equal to 22. Note that it's just the constant number, the coefficient in front of the variables, not the variables as well, because I often see that mistaken by students. So we know a, b, and c. We know that there is a y-intercept at 0, 22, because c is equal to 22. By a, because a is not negative, that means it's going to be pointing upwards because it's positive. We also know, because the absolute value of a is greater than 1, that this is going to be stretched, or it's going to become skinny because it has a vertical dilation. So we can tell by looking at the graph, we have our parent function of y equals x squared in the blue dotted line, and on the red dotted line we have our function y equals 2x squared plus 12x plus 22. As you can tell, we can see that it's pointing up. We can see that it's gotten skinnier, or it's been dilated to be skinnier. We can also see the y-intercept is 22. Now, obviously, by looking at the graph, I can tell where my vertex is, but we're not always going to have graphs or tools to graph them for us, so we need to convert to vertex form so we can figure out how this is translated up, down, and left and right, or we can figure out where this vertex point is, where the function has shifted, in this case, from being a decreasing function to an increasing function. So now we're going to start with our equation in standard form. So we have f of x equals 2x squared plus 12x plus 22, where we've identified a equals 2, b equals 12, and c equals 22. So that's the first step, is identifying our a, b, and c, and making sure that all of our items in standard form are on one side of the equation. So the other side is technically equal to 0. So the first step that we're going to do is that we're going to identify h by the formula negative b over 2a. We'll talk later about why that negative b over 2a comes about. I might even post a video in vertex form and doing this conversion with it later so you can see that, but we'll talk about why that negative b over 2a is a pretty important number in the future of this unit. But since we have a b here and a, and we know what b and a are, we need to use substitution. So I'm going to grab a, which is 2, put it here, and I'm going to grab b, which is 12, and put it here. So I have negative 12 over 2 times 2. So I get h equals negative 12 over 4, and h equals negative 3. So I'm going to put a h equals negative 3 because we figured out part of our vertex form already. So now we need to figure out the k. So our next step is to figure out what k is, and we do that by taking our original function, this f of x function, and substituting instead of x our h value, or our negative 3. So if this is our original standard form equation, f of x equals 2x squared plus 12x plus 22, technically what I'm doing is I'm substituting an h in there, which I'm trying to do. But the thing we know is that the h is equal to -3, so why don't we just substitute a -3 in there? So what we need to do is wherever we see an x now, we need to put a -3. And then we will solve and we will figure out what our k value is. So using the value of -3 now, I can solve. So the value of an input of -3 in my function will be, what's -3 times -3 squared? That's 9, so 2 times 9 plus 12 times -3 plus 22. 2 times 9 is 18. 12 times -3 is -36, so I have 18 minus 36, and I still have that 22. So I'm left with 18 minus 36 plus 22 equals 4. So now I know that k equals 4, so I've put it up here as k equals 4. So now we need to put everything together. So now we are at step 3, and in step 3 we are back into our vertex form, or we're placing our items in vertex form. So as you recall, vertex form is y equals a times x minus h, that value squared, plus k. Now that we know what a, h, and k are, all we need to do is use substitution, and we have vertex form. So if I know my a is 2, I'm going to replace it. If I know my h is -3, I'm going to replace it with this h. And I know my k is 4, so I'm going to replace it there. Be really careful with your signs here, because as you notice, I've replaced -3, but that negative sign, that x minus h, is still there. So I have x minus -3. So I have to remember what to do with that. So when we simplify after our substitution, we end up with y equals 2 times x plus 3, that value squared, plus 4. It became x plus 3 because remember I had x minus -3. So be very careful with your signs in 2 steps of this process. Remember, it's negative b. So if I had a -12 up here, I would actually have 2 negative signs because we're using substitution. This is a common mistake, and if you enter or get a wrong h value, you are going to throw off or get the wrong value for your entire vertex form. The other area with substitution to be careful is make sure you substitute appropriately and replace the appropriate values. Remember, in these parentheses, it's x minus h. So I need to put the appropriate values. So the big lesson here is to make sure that you are watching your signs throughout this process. And doing that, some practice with that will help to not make those errors or mistakes. So now we have successfully converted into our vertex form where we have an a, h, and k, and we know where our vertex is. So based on this, our vertex is at -3, 4, because remember it's x minus h in there. We knew a before, but we know that a is causing the graph to be skinny, and it's also going to be pointing up because it's positive and the absolute value is greater than 1. By this plus 3, we know we're moving left 3 units, and this plus 4, we know we're moving up 3 units. So if we think about where we're going with our vertex, we're moving up 4 and to the left 3, so we know our vertex from this way too is at -3, 4, and that makes sense, and it all comes together. So let's look at our graphs in Desmos now and just confirm that we've converted correctly. So I'm in Desmos, and in my red dotted line, I have graphed my equation in standard form. And remember, in standard form, we can tell that there's a dilation that stretched this or made it skinny. We can also tell because this 2 is positive that the graph is pointing up. And we know because c is equal to 22 that our y-intercept is going to be at 0, 22, which we can identify the point. Now I'm going to graph my vertex form that we just converted here. And you can see it's the same equation. That lets us know that we've converted correctly because we're not trying to change the equations. We're just trying to look at them in different formats. And you can see now we have the vertex point at -3, 4. We have figured out our transformations, specifically our translations that have happened outside or beyond our standard form because our standard form wasn't telling us that. So now I want you guys to practice with the homework assignment on doing these conversions and try to think about the indicators and what you know and what you can graph from these functions now because we've added another layer with a y-intercept.